their personal email address for sharing stuff so they can access it from home. But
It's Shelby.info@gmail.com.
The format that you have is not going to match. It's going to be a little ugly.
if you want it, it's no biggie.
Oh, well. Worried they're not. We didn't know if you're coming.
What's the crisis?
That's
You already-
it here. Present.
Hamilton, are
Yeah.
you good if I go ahead and start, or?
Please, I'm not even going to introduce you since everybody knows you.
All right. So I just basically wanted to share today two things that I recently actually used at work and how beneficial they were. And I feel like a lot of us can, there will be certain instances where we'll want to use them as well. So hopefully I did some of the groundwork that y'all can just take this and run with it. Basically, I'm going to start off going in detail on the JKI State Machine, why you would use it, how you use it, and just throw out some tips to make it much more easier for both yourself and others to maintain your code if you follow these couple principles that mainly Will shared with me. And then I've been very frustrated with dealing with Excel spreadsheets and LabVIEW. I feel like that's a huge shortcoming of LabVIEW. It does have built-in stuff, but it's pretty horrible in my opinion. So I love to use Python whenever possible when dealing with that. And so I was going to share just how super easy that is to do as well. By the way, I'm using LabVIEW 2018, so this is all capabilities that have been there for a long time. There may be newer, better ways to do it now too, so you may miss out on that. Apologies for that. So first off, on the state machine. So why would you use the JKI State Machine over other architectures? One is it's free, so you can just download it off of VIPM and use it right away. The big thing is it's a balance between simplicity and capability. It's a super simple architecture. It is highly capable, except that for if you need to have a whole bunch of stuff running in parallel, it's absolutely not made for that. So like our HWL applications, there's a lot of things that it would not work for. But for example, for a script checking tool that I just made, it was perfect for that because there's just a sequence of steps, no matter how many, they're always, if you want to do this one thing, it's like 20 sub steps you're going to do in order, no matter what. Super easy to organize that and for anybody else to understand how you're calling each of those steps and in the order and everything. So it's super easy to add to the project. It has basically all functionality built in right from the start so that you can just run it and it works immediately. And then you just add in what you need from there. And it's, from how I understand it, it's decently widely used. I don't know, I can't quantify that exactly, but and it's a way lower barrier to entry to understanding than Actor Framework, but it's less capable. So there's obvious reasons why you'd use Actor Framework over this for those parallel processes and stuff. So how do you use it? You just go and you install it. I included links in the PowerPoint too that everybody should have access to after. But yeah, you just go to VIPM, search for JKI State Machine. It has one other JKI package dependency. You install both of those. And then literally to drop it in a VI, you just can use Quick Drop or you can use the palette and you drop the whole state machine in, boom, it's ready to go. And it does have a bunch of comments in there. When I actually do a demo, we'll briefly look at them, then I'll delete them to get them out of the way because they can be kind of in the way. But it's pretty awesome how super simple it is to use. The main reason why this is so beneficial compared to other simple state machines is that right off the bat, you have everything set up for you and you have these cool little text parsers that basically allow you to do a queue setup without doing an actual queue. You're just basically dealing with text strings and it's parsing out for you, okay, this is, I'm gonna go run this state. And in the case of here, like you can add as many states as you want just by using a new line. And then in this case, you can add a comment and then you can even pass in data to a state as well. So over here, this is where, you know, each iteration you come in, it's going to go based on the state you go to, it's going to go to that state. And then this bottom line is going to be your actual data, if applicable, for that state. And then it's just maintaining all the rest of the states in there. And if there is no state to go to, then it just sits at a event structure. So one of the ways to make this super easily understandable and usable by others is to follow basically one major principle, which is do not just haphazardly add states, call states. Instead, force yourself to, it's already pre-organized for you. This is all just default drop in. You get all these states baked in. But specifically, if you're going to call anything, even if it's only one state, you should always do that from a macro. And so when you have, say, a button is pressed, your event structure recognizes the button press. Don't really do anything in there. Maybe one simple storage of data for which button was pressed or something like that at the most, but then immediately call a macro. And then from the macro, which is just another state, you'll list all the states that you actually want to do in order there. That just makes it where it's super traceable as to where everything's being called. Will, feel free to add anything in here too, because I basically learned this all from you recently. So, all right. So the typical flow is I kind of touched on already, and we'll see here in just a bit, is that you'll have a project, you'll have a main VI that contains your state machine. When the state machine starts, it runs through certain initialization steps, which is already baked into, and you can just add your specific stuff in there as needed. And then when a user action happens, it triggers an event. You would trigger a macro in this case, right? And then in the macro, you would add whatever sequence of states that you want to do. Super often, at least I found myself, this is also built in. It has a UI cursor set, and you can set it to busy so that people can't click on other stuff while your application is actually doing things. Then you'll like manipulate some data, then you'll update some UI indicators, and then you'll set the cursor back to idle so that they can use the cursor again. Super simple. All right, so moving on to Python. Now, as I touched on already, really, I just am so frustrated that LabVIEW doesn't have baked in good Excel functionality. And so I'm just trying to get around that. But Python has a library that does everything basically. So this could be used for anything that other LabVIEW shortcomings that y'all find. And if you do find some, please share it with us so that we can also use that. This is actually a picture of their baked in functionality, but it's with their report generation toolkit, which I just found out about yesterday. And it pops up the Excel spreadsheet though, when you're like reading data in. It seems like most of the stuff is geared around actually writing to a spreadsheet rather than reading it and interpreting it. It does have some capabilities in there, even with formatting and things like that. You can find ways to do that. But it's always going to pop that UI up in the background, and it's using ActiveX. And so it's going to be very, very slow and frustrating. And for us, we're often using unlicensed Excel, and it's going to bitch at you for that and possibly cause problems. So I did try to use this third-party package called Pkwy. It advertised to be everything I wanted it to be, where it was not using ActiveX. It doesn't pop Excel up. It's basically doing everything like Pandas does programmatically in the background. However, if there's any sort of weird formatting stuff going on, for example, like you hide a bunch of cells or something like that, it doesn't interpret those. And then if you make a change and save that change, it like blows away formatting and stuff like that. So I think it's some guy in like Ukraine that wrote this or something in the Eastern, Europe or something. So not super reliable, unfortunately. But LabVIEW does have native support for calling Python even as far back as 2018 or before. So let's leverage that. All right, so how to do it. The hardest part is you got to determine a pairing of 3 different things. You got to use a LabVIEW version, including the bitness of LabVIEW, by the way, Python with the same bitness, and then the Python libraries that are also supported by that Python version that you pick, and all 3 have to be compatible. So it was a little difficult for me to find With 2018, I was very limited on pandas. I actually had to go back to like one of the earliest version of pandas in order to get it to be compatible with Python 3.6, which was the latest that I was allowed to use with 2018. So this is one of the frustrations that you're going to have to deal with, just to make sure that you have cross compatibility. Now there's, as Colby and I were talking about just the other day, there's two great libraries for manipulating spreadsheets with Python, and this isn't really about that, but just know that Pandas is much faster and much more capable from like a data analysis perspective, but it doesn't preserve formatting. So if you're actually saving to a spreadsheet, it's not very good. And then if you do want to save stuff to a spreadsheet without overwriting formatting, OpenPyXL, awesome. However, I don't think there's a version of OpenPyXL that works with 2018 LabVIEW because it doesn't work with 3.6 Python. You have to have later than that. So you're kind of limited there.
Can you use both?
Yeah, you can absolutely use both. There are some other minor differences that would be more pros and cons on both sides once you get into the weeds of that. So like how simple it is to read a value from a cell and to save a value to a cell. OpenPyXL is actually really awesome for some of that. Pandas seems more geared towards doing like large data analysis tasks. So it may be more tedious if you're just trying to look at like one or two cells here or there. So I'm not an expert on it though, but I mean, there are times where you may want to use both. Yes, Hamilton.
Can you describe the difference between fast and slow?
I can't quantify that exactly. I'm going off of what other people have said,
Okay.
but the way that pandas, one of the reasons why pandas is not good for formatting related things is because it immediately ignores all of that and ingests the data and creates a data frame, and it doesn't care about formatting. So it allows it to manipulate large sets of data much faster, whereas OpenPyXL inherently does not do that. It treats everything individually, preserves data about its formatting and things like that. So I would imagine it's related to that, but I'm not 100% sure.
But it's not like infinitely slow. It's just somewhat slow.
Yeah, so I've manipulated thousands of spreadsheets with OpenPyXL, changing multiple, like interpreting maybe like 100 cells within each and manipulating a few cells within that. And just for an idea, it takes roughly like 2 minutes to do that with like multiple thousands of spreadsheets.
Yeah.
So it's not huge.
I just Googled it and it says, I guess Pandas kind of operates using memory, and then the OpenPyXL does like sensing.
I was waiting for Josh to throw out some here too, because he said he was going to be very critical of the technical question. Oh, that was on the state machine. That. All right. All right. So on the how for Python. So first off, once you do figure out the correct versions of everything that you're going to use, download and install the appropriate versions. I just, as a default, always recommend that you install Python for everybody, so you don't have to worry about user permissions issues. And you select adding it to the environment variables and double check that your bitness matches your LabVIEW bitness. And then you'll do the same thing with Python libraries. If you're online, oh my God, it's so easy. Just pip install whatever you want. It auto installs all the dependencies. If you're offline, for example, with Pandas, you have to manually install, this is Python, of course, but you have to manually install all these others, and you have to do it in a specific order or they'll also bitch at you too. But basically you're just doing, so you go and manually download from pypy.org, which as I understand it is where pip will normally look anyways if you're online. But you have to go through a tedious process of choosing, finding your library that you need and then choosing the appropriate version of that library and the appropriate, like processor type and bitness and everything. So be very careful about what you download from there too. But then you'll just pip install each one. And if you don't get any errors, you're good to go. Every time I just keep trying each one and I get an error, it's like, okay, I got to install this other one first. Okay, now I got to go do that one. I just kind of brute force until it works. But Question?
Yeah. Have you done anything with something like Docker with Python? And the reason being with all this complexity of keeping up with versions.
So that I have not used Docker in a long time, so I'm not very experienced with that. I do know that only later versions of LabVIEW, they will support Python virtual environments, where you can also set up stuff like Colby had showed me a while back. That's mostly outside of my wheelhouse, so I'm not a good person to ask about that because I usually I've got like 2 versions installed and I just switch between them as needed on mine. And I don't use virtual environments or stuff like that. I just install everything that I need right away. That's why I was very adamant about, I just want to bring in my GTAG because I don't want to set it up on anybody else's. Yep. It's frustrating. Yeah, I think that definitely could be an option. I'm not the guy to ask about it. Sorry.
Yep.
All right. So how do you use a Python node in LabVIEW? Well, it's super simple. You have 3 different Python things. You can do control space, Py, and you'll see the 3 options: open Python session, Python node, and then close Python session. Open Python session, you just tell it what version of Python that you need to use. Of course, that has to be pre-installed and set up. And then you just pass out that reference to your Python node, and that's where you're actually going to call a specific function. And so because you're calling a specific function, you need to tell it where your Python script is at, and then the function name that you're calling. And then over here, you can drag this down and you can get as many inputs as you want. I'm just using 1 string input here. And then you also have to specify, kind of weirdly, on the left-hand side, on the gray part, you need to specify what your output type is. And your output will come from the gray bar too. I always miswire it and start with here, but your output comes from the gray bar on the other side, and it'll expect to return the same value that you told it, the same type. And then when you're done, you close the Python session. And if you're going to be calling, like reading thousands of spreadsheets, just open it once recursively or whatever, just repeatedly call the middle one and then close it once at the end. And it should be as fast as possible that way. So just a couple tips on here. As I alluded to before, Pandas is great and fast, but only for reading. Don't try to write with it. And then I already mentioned the fact that OpenPyXL is not even supported with 2018 LabVIEW. And then just mentioned that. So let's see. As anybody that uses Python often probably knows, the first time that you go to run a script after you make a change to it, it's got to compile it. And it saves that PYC file to a cache folder so that next time you run it, it's super fast. But the initial time that it has to generate that file takes quite a while, even if it's a super simple script. Especially quite a while if you have a lot of includes libraries that you're referencing in there. And then I did run into where if my Python script threw an error and I was catching that error on the LabVIEW side, it was not very descriptive. So I suggest just handling it on the Python side if possible, but it depends on your use case. And this is just a modification of the other one where it's just a hair more complicated, but not much. Basically, in this case, I'm actually reading a spreadsheet here. And so I'm telling it it's a 2D string array for the output. I'm still just passing it a string, but in this case, it's going to be the spreadsheet path. And basically the function in Python is super simple. I do have to import pandas and I do put it in a try block because quite often you'll have a spreadsheet open and it's going to throw an error because of that. It'll try to read the open locked file and so just throw it in there. I catch any exception, and in the case of that, I just return basically a blank 2D array. There may be a better way to do that, but that's what I came up with so far. But if it doesn't have an exception, basically you just create a data frame out of the spreadsheet, and then you force all of the data types to string because it'll try to keep numbers and stuff like that, which this LabVIEW is not going to be happy with. You'd have to do some sort of cluster of items and things like that, and it could get pretty complicated. So I force them all to strings, and then basically I just it'll also Pandas weirdly puts like nan or something like that if it's a blank cell, so I get rid of that, and then I just return that. So super simple, and that's what I want to demo right now, I think. So any questions?
And it may be for afterward, after you get through the demo, but I'm curious, how do you use this? What's your use case for the Excel?
So my particular use case I could tell you about is it actually is both a combination of the JKI State Machine and this Excel reading. Is we're forced to use offline computers with a unregistered version of Excel. And so the way our computers are currently set up, you have to knowingly ahead of time prepare by pre-opening a spreadsheet, looking past the warning that it's not licensed, and then whatever application that has to look at spreadsheets, usually it's in the case of looking at test procedures.
That's what I'm asking about.
Yes.
So it's for test procedure,
Yes.
like almost like a recipe or
Yeah.
a sequence or something.
Do this step, do this,
Yeah.
do this. Each line is a different step that it's doing. And in order to ingest those in whatever manner we're trying to do, whether we're reading it to actually automate it or we're checking the validity of them, whatever, we have to actually pop up Excel in the background multiple times, and it takes so long. It's very frustrating. And if you forget to pre-pop one up and click past that thing, it throws an error, and then you have to restart the application. And it's very frustrating. So it's a way to get around that completely, and then it's much faster. And
I was just wondering what kind of data you're using in Excel.
Exactly that, which Will's alluded at. It's probably not how he would have done it in the first place if he was designing the test procedures, but I mean, it's what we're stuck with. It does have benefits, though, I would say, is you can do fancy formatting to try and make the test engineers happier when they're looking at it and adding and changing things, because it's clear what columns belong to what because they're color coded. There probably still are better ways to do that.
Okay. Thanks.
Have you tried this with the numeric data? Do you still have to read everything into strings, or?
Yeah, I'll just convert it to a number if I need to interact with it as a number, but I'll always ingest the entire spreadsheet in. And it's also pretty cool in that it doesn't matter if it's a jagged array. If you have more columns and rows or whatever, it deals with that. It just puts in blanks to make it even. And then you can then manipulate each cell as you determine, this is, I know, is the start time cell. So I know it's going to have a number that represents seconds since this date time. And I'll do whatever with that by converting it elsewhere in the LabVIEW program. I'm pretty sure there is a way, though, that you could still use pandas without forcing everything to string and deal with that by using, like I mentioned, clusters and things like that. But I have not tried to do that. It sounds like it's more effort than it's worth at this point in time for me, at least. Yeah.
Can you go back to that slide where I think the state machine is that little pink box, towards the beginning in the.
Like that small guy?
Yeah, so it's an event. So that's like the pink box, the state machine, and then it's inside a event thing inside of a WoW thing.
Well, we're going to go into that as soon as we're done here. I'm going to do the demo, and I'll step through it in the demo, probably a little slowly, and so you'll get crafty for that. But we'll go over exactly everything there.
I do have one question about that last bullet point. You're talking about, so use this for linear applications, but not for parallel. What are some of the drawbacks of using JKI State Machine for parallel processes?
It's not made for that. You would have to spawn off a process, find a way to interact back with it once that process is done. I mean, there's always ways to do things, but it's just, it's very good for, listing, here in your macro, you can list 20 things and it's super clear. These are the 20 items that I'm going to do. Each one does one discrete small thing. Very organized, simple, but that's only works if when somebody presses this button that you're going to do all those 20 things in order and that they don't depend on like something finishing at an unknown time on another one and then incorporating that back in, at that point of complexity, you probably would want to go with something different. I would imagine. Will can comment on that. But
Yeah, a big part of that is because of where the event structure is. In this, it's single loop, so it's not producer consumer. So you fire the event and you have to finish all of your states before you can get back and handle another one. That's less the JKI State Machine framework, like the individual VIs, that little white and green guy that does the queue building. That's less the limitation of those. You could split it into 2 loops, and you could have you could pull the event structure out of the template that comes with the JKI State Machine, and you could use the state machine without the event structure and split it out that way and make it a producer consumer. Then it would be more suited to something like that.
Do they have a JKI queued message handler? Or
No, it's just like this. It's just the state machine setup.
okay.
by the way, also JKI has a lot of great documentation and training on this. It costs lots of money though, so you can use it for free, but you can't do the training for free.
So that's how they get it.
Maybe it will be YouTube video.
Hopefully a good one. Do we want to continue for the code demonstration or not?
It's up to you. Do you want to webcast that?
I mean, I don't know how I would webcast that unless you're.
You want to
with
point
your
that
phone.
camera at you as well. Right now, in the future, I'll probably sit down there and point the phone, and we could do a picture in picture. But since it's the first run, this
You're welcome to try that if you like it.
as long as you're good with whatever you're putting up there. Don't put any secret things, obviously.
Okay. Don't look everybody for a second.
1 second.
Close your eyes.
It worked for the Epstein video.
Oh,
We're gonna have to edit that out.
Let's see.
I think this marriage is probably built by Jeff Bezos' marriage.
It's a little glary now. It's the only
Bill
problem.
Gates refers to his divorce.
Does that have multiple switch options? Is there any way you can shut off the front lights? Or you can turn. That's not much better. It looks like crap, pretty much. Oh, that's bright stack too. It's as good as it's going to be for now. So whatever, we'll fix it the next time. It's probably better with them on actually.
Yeah,
because now it's just
like
washing it out. Yeah, the webcam just doesn't auto bounce very good. So whatever, we'll fix it the next one, the first one.
Describe it
Yes, we
very
do.
well.
All right, so I just opened a blank project. I'm not even gonna bother saving it. I know that goes against all principles. But, everything back. So blank project, make a new VI,
Yeah, it looks like.
and then I'm just gonna right click. You can do control space and JKI, or you can find JKI down here.
Would it show more of the screen and therefore do it like that some better?
Screen still.
Yes,
It's pretty much just shit. I might be able to do this here. You can keep going with it for a second.
Can you run screen recording? Like built in.
Possibly, but I'm not going to bother with it. It's too late for that. So see this giant README here? We're just going to delete that, but it's just giving you a couple notes that I've actually covered all these anyways, so it shouldn't be a big deal. And then they have some notes about how the syntax is for adding each things that we covered, about how you add comments as well, or add data to pass into each of your states.
I'm going to stop you for a second.
Sure.
I'm sure that YouTube had caught it, but I don't think we did. Did you drop something on this blank VI?
I did, yeah.
Can you do that one more time? I mean,
Yeah.
don't actually do it, but just show what we would have done.
Sure. Blank VI again. I didn't do anything of consequence yet. So you can either do control space and then find JKI State Machine. I already installed the 2 prerequisites for it. One of them is specifically the JKI palette, which I'm using here. And then I don't want support. I want the actual state machine.
Thank you.
Boom. Everything is
Right.
there.
There you go.
Immediately-
That's what I thought.
By the way, immediately executable, right? So it dropped because of my low resolution, it's hard to find the OK button. That's actually a stop button, by the way. So you play it. It did a whole bunch of initialization things, and then it's sitting at the event structure right now. The only event it cares about is if I either close the panel or if I press OK. Both will stop it. So boom, good to go. And then just get a little bit more into weeds here. It's currently not set to have a timeout. It can sit at the event structure forever. Doesn't matter. I don't like this copyright there. I'm gonna get rid of that. And all right. So what I would like to do is I'm going to start out by doing just text manipulation without Python, and then I'll build in the Python, and then I'll build in reading from an Excel sheet, and hopefully we can get through this within 25 minutes. Please don't be too critical of me. So first off, let's look at what this actually does. So see how it says macro initialize outside of the while loop? That's adding the first and only actual state for it to go into. And so that boom, that goes into the shift register. Or remember, we have two shift registers. The top one is for our actual data. The bottom one is for our states. And so we added initialize to the states. And so let's go look at what macro initialize does. Inside of macro initialize, it's using there's only two different types of these text parser fancy green VIs. One is where you actually pull out your state for use right immediately there, and your data potentially with that, or your parameter that you're going to pass in. And then there's adding to it. If you add at the top, it adds it in normal order. If you add at the bottom, it can stick that in front, I think. I'm not exactly sure. I've never used that. Yeah, state is at back. Oh, sorry, you add them to the back if you do it there. Those data initialize. So this is where you would add your own data in here. So it gives us a string data to start with and a Boolean data. We can add our own, custom control with a ton of data in it here, which is what you'd normally probably do. And you bundle that in there, the default values for everything. We'll just leave it for here for now.
Wait. Question.
Yes.
On your little green guy on the right, basically, does that mean that when you bring it in on the output of the green guy on the left, that
It's
it
doing
basically
nothing here.
all
This one over here is where it pulls the states out for
Right.
the current state, and then that state's data, and then has the remaining states that it also passes in. And this is essentially just being a pass through right now because we don't have the front or the back. It's just passing.
It could be in case you need some initialization states after that.
But you should add that to the macro instead of adding it here. So it is kind of odd that they put it there. But good question.
okay. Thanks.
So the next one, I believe, was initialize core data, which as that whole section kind of indicates by the name, this is stuff that you probably don't want to change. It's just built into the JKI State Machine. And if you look at it closely, it's just configuring some stuff for the opening and closing, it's just keeping a reference in mind. I think it's going to help later when you want to shut down so that it's able to shut down. It has the references stored and everything to shut everything down. Don't take my word for that. This switches.
Does that mean that the data is the data for all states rather than the data for the state that's next, if you will?
When you the data that's passed in the top shift register, is what you would normally interact with. Like you'll pass in default data to start, and then you
It is the data that describes,
I would say there's three different kinds. So I would say you have all of your application data, regardless of what state you're at, you're just always passing that through the top shift registry. You have your state itself that you're controlling is on the bottom, and that includes like a queue of states as well. And then your data for a particular state, like uniquely for that state, is passed in as a text string here. So in this case, for UI front panel state, open is a parameter that you're passing into that. And that will be available via this bottom thing right here.
I think of something like for instance, if you have a login facility, so you're going to have a user login, so he has to provide a username and password. When he does, you come up with a session ID and maybe his permissions, his authorizations.
You would store that in the top one.
That's what I think of as the state data, or
You would store that in the top one, definitely. Anything other than just a simple text string to manipulate specific state acts.
So it's all the data that would be being used in this state machine.
And we're going to pass some data into here in a second, not much. We'll see that. So UI initialize that real quick. And I love how it's organized into like, okay, I'm doing stuff with data. Okay, I'm doing stuff with the actual user interface. Try to maintain that separation there, and it'll make your life a lot easier. UI initialize in this case is doing nothing. I mean, there is no UI. And then front panel state is just set to open. And then there, on the opposite end of that, if you go to the event structure and you look at the OK button, which is really the shutdown button, you can see that all it does is it calls the macro exit, and then you'll see where it's using some of those references on initialization to shut everything down. It's doing, depending on if you had closed panel on exit set upon initialization, it's going to do either one of these, either nothing or just close the front panel. And it's going to do whatever cleanup you have, which is empty right now. These are all just placeholders for you to use as necessary, which is awesome. That is just baked right in there. So being cognizant of our time limit here, I'm going to just drop in real quick here. So I'll do a string control, and I'll say name. Okay. My numlock screws me up all the
Those
time.
backlit keys are really helpful.
They're not backlit. And then we'll do a string indicator, and we'll call that greeting. All right. And so what I want to do, actually, let's also just add a new button. Do another OK button. But this one will say like process. And we won't leave the link one. And make it a little bigger because I can't click things very accurately. And we'll change this to but that was dropped. We'll make this process. And so we'll just need to go to our event structure, and we'll just add a case for that guy, for somebody pressing the process. So we'll just add event case, process, value change, okay. We'll just dump that guy in there. And anytime you add anything, make sure you connect three things. You're going to cause a problem. So you got to connect your error wire. I'm not going to manipulate any data at this point here. Now I do want to add, in this case, always you're going to add a macro, right? So I'm going to add my own new macro here. and I'm going to follow their naming convention as well, and I'll just say process. And so now I'm going to go here to my macros, and I'm going to add a new case. And first off, I am going to, remember in a macro, you're not going to do anything but call individual states now if we're following our convention here. So I don't want to do any data manipulation, nothing like that. I'm just going to, I'm going to create a list of what I want to do. So I'm going to do something with data. So I'm going to do grab name, and then I'm going to do something with the UI. I'm going to do update greeting. Okay. That's it. And then I can go add those in. So I'll do now you can do this at different ways if you want. This is just, I'm trying to follow the convention where I'm not manipulating data or anything like that outside of just a normal state. So it may seem a little tedious, but it's going to make things easier in the end, I think, if you do it this way. So I'm not going to add any states to it. So I'm just going to pass that through. But what I want is I want to grab the name and I want to package it into my data. And remember on for data initialize, not the core data, but the data initialize, I have string data I can use right now. So I'm just going to use what they gave me. I'm not going to modify that at this point. So I'm going to go back to
Grab name.
yes, thank you. And I'm going to do cluster bundle by name. Your string data. Boom, that'll be the name. All right, so now I got the name, and then the next thing I wanted to do was the UI, let's see, what did I call it? UI update greeting. All right, and so I need to update that user interface indicator. So I'll do unbundle to grab that I just bundled in. And string data should be the name. And then I'm actually going to, so I probably should have done this. So let's do it the right way. I'm not going to manipulate data here, right? So I actually should do, instead of grab name, I should make the greeting from the name with using the name here automatically. So I'll just manipulate that real quick. So I probably should call this, call it make greeting. And then I'll just have to change that in here. And then on UI update greeting. Boom. All right, so let's just see if this works. I got to run arrow. Name, Josh, process. Josh says hello world. Okay, oops, did something super simple. All right, good job, Josh. You're at kindergartner level. Cool. All Now let's do the same exact thing, but let's do it with Python, just to build up here. And then if we run out of time, we may have to skip the actual Excel portion, but that's in the presentation, so you can see how to tweak it for that too. But here in the make greeting section, I'm actually going to use Python to make this greeting instead. I'm still going to take the name data, but let's go ahead and just create a very simple Python function. All right. So let's call it greeting here as well. And we'll pass in the name to it. And then we'll just return name. Consistent there. All right. And let's see. So quick drop, boom, Py, Python node. Won't be here with quick drop. But
Why is that inside and not outside of the thing? Because you said you don't want to like open, or I guess it's only part of the greeting for.
I'm manipulating data, but I'm within a data state. So I think that follows convention. Probably you would package this all into a separate VI as well, and this would just show name going into VI and then your output coming out. But I'm just, for quick purposes, going to do it all right here. Yeah, I think it follows convention.
We might open session and store it. Like you have
Yeah.
a case when you first initialize that opens the session and then it's a full time use.
And that would be part of potentially like your initialize, is you grab that immediately and add that to your data before anybody even does anything.
Yes. Okay.
So the input to my function is going to be name. And I just so happen to also want my output to be a string. So I'm just going to use the same thing to define the output type. And then my output is going to go backwards over here. And this is the path to the script. So and it's called, I think, lowercase.
On Windows, it shouldn't matter.
And then it needs the function name. Was that make greeting, I think? Camel face. Is what?
Make greetings.
Jesus. So I'm gonna, let's see, I already wired this. I just made it horribly placed over here. Oh my God. All right, there you go.
You have to define the Python type on the open session.
Yes, thank you.
What happens if you don't? Does it just default to like, or it just doesn't work?
I think it's gonna give me an error. Yeah. In fact, I think it's errored right now because that's not defined.
Oh, it's required.
Yes, that was exactly right. And I just happen to know I got 3.6 installed and is great for this. So hopefully this works. And
Did you save your Python? I don't think you did.
I will definitely. Yeah.
You did. You did.
Yeah. Okay, cool. Cool. So let's try it. So let's change it to something else. Now it's got to compile the Python script. So boom, there it goes. It just took a second, but now it should be immediate as I change it. So pretty immediate. So cool. So we've got 6 minutes left. I don't think I can actually do the whole grab the Excel in that. I might go like 5 minutes over. If y'all want, I can do that real quick. It's up to y'all.
Can we go with the lights on? I'm like, get the sleeping lights on.
One time.
That's BS. All right, I'm going to continue. Josh, you're welcome to leave. See you later. Bye. All right, let's have it do both at the same time. So let's just I'll add a file path control so I can select where the Excel spreadsheet's going to be that I want to read, and then I'll just display the sheet data. So super simple. So I'll do a and And let's make sure these are somewhere reasonable. All right. So let's go ahead and process is going to be a universal button that does two things now. So in the macro process, I'm still going to have it do everything it's doing here, but let's go ahead and have it do another data item. Grab spreadsheet and then UI update array. And then let's go make those. Okay. I'm just going to connect these initially just to not forget. And all right, so everything should be functional. It's just not going to do anything additional right now. So let's go ahead and add the functionality. And in fact, you know what I should have done is just grab all of this. Not this. Should have just copied this guy when I made the new. Yes, so we'll have to add one more thing, which is super easy to do to the data. All right, so I'm not going to write from scratch that same Python script, so I already have that in there as demo 2. It is going to take in a string, but it's not going to be this string. This is a duplicated name. I didn't mean to grab that guy. So we're going to grab the path here, and we're just going to convert that to a string. And we're going to pass that in. And we're going to define a 2D array constant. And we're going to define our output as a 2D string, right? And then we're going to bundle that into here. But first we got to go add this to our app data, let's call it.
Is the function name supposed to be the path, or is it also make tree?
No, it'll change too. I got to update that too. One thing at a time. So under the data initialize, we have our string data, but now we need more. So as the thing hint here is alluding to, we need one more thing, not two. And it's going to be just a blank 2D array to start. And let's name this. Array data. All right, so boom, now we have 2D array data as a slot in our data. And we can now save to that. So under grab spreadsheet, I do need to update this. Let's look at So this is my pre-written script here. And the function is called grab spreadsheet. So at least I'm consistent here. Not in my capitalization spaces though. All right, so that should take the path as a string in and return a 2D array. And then we will bundle that into here. And it's not this guy. I always screw that up. It's you define your input on the gray part and you define your output type on the gray part and your output comes out the gray part too. I don't know if you can do multiple outputs. I'm assuming you'd have to do it as like some sort of, I don't know if you'd pass it out as a tuple in Python and then interpret it as a cluster in LabVIEW. I'm not sure. That's a good question for you guys to report back to me if you get a chance. All right, so this looks good here, and then let's just display it under update array. So here's our array. And let's see. All right, so in theory, we have everything in place for this to work. So let's go ahead and run it. And let's try Will this time. There's 2 people here, so that's double duty. And then let's define our path for our spreadsheet. So the spreadsheet we want to look at is test here. I didn't show you guys a spreadsheet yet, but we'll look at it through this, hopefully. And then click process, and it should do 2 different things with 2 different Python scripts, completely different scripts and functions, hopefully. It does have to compile pandas right now, so that's why it took quite a long time. But again, it's only the initial time. And notice it did update both. One thing to note here, though, and this is more of a pandas thing, is that it ignores the first row all the time. So if we actually go and open test, headers ignored is the first there. And it's because it ignores the header. There, you can give it a command so it doesn't. It just assumes that you have headers there that you don't want to. So anyways, questions?
Did you want to show us your Python program for reading the spreadsheet?
Oh, I can't show you the other one I was working on. You're talking
The
about
demo2.py.
that is this. But if you wanted to look closer at it, I ran this. That's how it grabbed that spreadsheet. Yeah.
Very good.
I have 2
Yeah.
almost identical
No, that's good.
data. Yeah, this is the grab spreadsheet.
Okay.
Yeah. Cool. Sorry I'm late, guys. 4 minutes late.
I was just going to ask a quick question. What benefits do you see of the JKI State Machine versus just a Pkwy machine handler?
So I am a newly minted, barely CLD. So keep in mind my experience level here. I don't have a whole lot of experience using the different architectures. I have used Actor Framework quite a bit, but from a perspective of just tweaking things and not like building the architecture for a new application completely from scratch by myself.
Yeah.
So I'm kind of a bad guy to act about that. The queued message handler, though, I think would be better at being more responsive, as Will alluded to, because it's allows you to queue up many different user interface actions instead of being frozen while it's doing a series of events.
That's producer to consumer.
Sorry.
Queued message handler would be like, why would you use this versus getting rid of the JKI functions and just using queues?
Well, I would say it's because it's super easy to just write text line by line, and even like within that, you can also pass in data as if it's just a short text string, as well.
Yeah.
So if that's all you want to do with the queue, this would be superior. But if you,
I forgot to accept that.
Yeah.
Yeah, you'd have to.
Any other questions? I have lots of questions, but
So the paradigm is you've got your macro, right? That on Q's your next set of states. Then is it in data, you manipulate the data, and then UI, it's just you update the front panel.
yeah, and you are welcome to make even more, concise groupings too. You could even break down data more, whatever. This is just what they prepackaged give you, and I highly suggest using the macro thing behind it. But then how you organize the other sections is completely up to you. I had a lot of similar data stuff, and this is probably not optimal, but I still did data, but then I did like analyze 1, analyze 2, analyze 3, but they all started with data. I could have made different sections for that too, but
It would be cool if they incorporated some sort of protections for preventing you from passing in a state that did fit that paradigm.
anything additional though, because we're exposed to the underlying structure of the code and everything, like it would make it necessarily more complicated too. I love how just simple this is.
It has like a real basic version of that, because it'll go to the default case and throw an error if you give it a state that it doesn't actually know about.
Okay.
That is true.
Rick?
But basically fancy text parsing.
Cool. Very good. Any more questions? Thoughts? So I heard there are a couple of guys who want to present. Takers. For next time, not today. August,
I had mentioned
September.